So now in this video we have a weird looking setup if you've never seen it before. So you can see we got two series resistors right there going across the power supply, and nothing is attached to where they are connected together because we're going to get a signal voltage there. So technically nothing should be electrically connected to it other than being able to look at the voltage, which the multimeter will do in a little bit. So we have 12 volts across these two resistors. Current's going to flow through them. We don't want any current taken away. So this is just something other stuff can look at the voltage for the most part right there. 2,000 ohms of resistance, 12 volts across it, because their resistances add up when they're in series. We'll get 0.06 amps, 6 milliamps of current right there. I did the math. And so these are 1,000 ohm resistors. If you got 6 milliamps of current going through it, because remember all series components have the same amount of current going through them, then a 1,000 ohm resistor with 6 milliamps of current flowing through it, you multiply those together, you got to do the math in amps though, 0.006 amps, you got 6 volts across it. Pretty straightforward. So that's because they are equal value. They have half of the total voltage across them right there. Something to be aware of. They divide up that voltage. And this was saying 6 milliamps earlier. Now it's saying 5. So this probably thinks it's a spec below 6 milliamps of current. So we'll just get the multimeter. So here is the multimeter. We're going to set it to measure voltage. That's what's most important right here. So we saw 12 volts at the supply. So I'll measure that. This meter also, I don't have to move the red probe for anything but high current, and never have to move the black probe. So I got these backwards, but we got a negative voltage right there. That's perfectly fine. And I'm going to put them in the right way. So measuring voltage and current, if you get it backwards, don't worry. You'll just get a negative voltage. So that's the voltage we got. Now, we got 6 volts at this spot right there. So there's 6 volts across that resistor, and there's 6 volts across this resistor because they are equal value resistors. But they're not perfectly equal. So here you can see we got 6.35 across that resistor there, and then 6.026. So this resistor on top is just slightly higher in resistance than the one in the bottom. And to measure current, I just kind of figured I would take the little jumper down there headed to ground, and we gotta put the current through the meter. So we're just going to measure milliamps right there, milliamp range. If there's numbers, make sure it's set to a number higher than you're going to measure, or else you'll probably blow a fuse. So then you'll have to replace the fuse. Not a huge deal, but better to not do so. So there you can see just a speck above 6 milliamps of current. Now we have this resistor coming to a dead end, so current will not be able to flow through those. Once I get this off of measuring current, we do run a risk then. Instead, I'm going to put it to resistance right there. So I could disconnect that from the positive supply as well, but we're going to keep things a little bit shorter. So doesn't matter which side you put positive and negative for measuring the resistance right there. And so we got 0.980. So the other one, that is, about 2% off. So these are supposed to be about 1% off, but they're cheap resistors. So I think a lot of them are more than 1%, what's called tolerance. So it's supposed to be 1,000 ohms, but could be 1% higher or lower. And there you can see 0.982 right there, just a speck higher. That's in kilo ohms, by the way. So 1 kilo ohm would be 1,000 ohms. So this is 982 ohms right there. So just a speck higher in resistance than that lower one. That's why I had a speck more voltage across it than the lower one right there. It's whatever percentage of the total resistance across where you are measuring that determines what the output voltage will be. So we were looking at the voltage in relationship to ground, which you normally do right there. That's half of the total resistance, so we got half of the total supply voltage. And that was my hand was touching this. You could see the resistance, so I'm just holding it between my fingers right there. That's what those numbers are doing. So in any case, turn the meter off. Definitely get off measuring current. As soon as you're done measuring current, you can set it to a voltage or something if there's a power button. But here we have an off setting, so that gets you off measuring current anyways. But yeah, that's the basics right there. Two equal value resistors are, easy. There's math for calculating voltage dividers, but generally speaking, like you use a trim pot to, adjust the voltage that you want and stuff. I don't really run into having to use math to calculate the voltage of a voltage divider. Usually I use like a normal fraction, half, a third, or whatever. We could use 3 of these resistors. There's 2,200 ohm resistors, but if there was a 2,000 ohm resistor, I could set a 2,000 ohm resistor up there, and we would have 4 volts across that one, 8 volts across that one, and so on. You don't have to make this terribly complicated unless you're in an electronics class where they make you do a lot of calculations. So in any case, that's it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.